What I did for version 1 is I built a simple jig to drill this with. Now, when you're drilling the top of the case, that's obvious, that's easy. It's already sitting flat, and you're drilling holes which are perpendicular to the surface of the top. Now, when you're doing the sides, you know the sides of the Monotribe case are beveled, so that presents problems. If you would clamp down like this and you would drill like this, your holes on the sides here are not going to be perpendicular to the side of the case. They're going to be bent, which means that your screws, when they go through those holes, the cap of the screw, the button head, is not going to sit directly flat with the side of the case, which means that when you're tightening them, you're going to dig in to the side of the case, and you'll probably end up scratching the paint. Basically, you'd like to have your pots and your switches running out perpendicular to this case. So I built a jig for that to hold it the right way. And what I've done is just very basic, simple thing. Just taking a flat piece of wood, and I've got 2 pieces of molding that are 90-degree molding that I put in there that makes a little fence I can butt against. And then I've taken, these things are little plastic shims that you use for doing flooring. When you're putting in wood flooring, they sell these by the bagfuls at Home Depot or some kind of hardware store, which have little spots on them. You can decide how much, the farther up you ride the shim, the more of an angle you'll sit at. And I've just drilled a couple little holes in them, and I've got 2 different sets of holes marked here. So what I would do, for example, let's say if I'm doing the front, I've also got little notches you can see here in the wood, because the back has the little brackets around the power switch that are molded into the case, and so that allows those to sit down flat in there. And then when I take this other shim and put it back there and a piece of wood, I can clamp these 2 together. I clamp it down tight, and what I've basically done, I don't know if you can see that well in the camera, I've made this surface here parallel to the plane of the wood. So when I drill, my holes are exactly perpendicular to this side, and the same thing will work for doing the 2 long sides. Again, once I get this clamped down, this side here will be parallel to this side here, which means my holes when I drill are going to be perpendicular to the side. And I do that for the 2 long sides and the front. Now the back is a different story, because with these 3, we want these plates, we want the knobs and the switches and stuff to come out perpendicular to the sides. But with the back, we have this connector plate that has the jacks on it, and that connector plate is going to sit flush to the inside of the case. And so the connectors, the jacks themselves, are going to be parallel to the top edge here, not perpendicular to the back. So when we drill the back side, we actually want the angle to be a little different. We want the angle in such a way that we're drilling perpendicular to the front of the plate, not this plane. So that's why on the jig position, I can undo these 2 little shims and I can slide them back. And so it'll bring the corner, the tip of the shim back so I can get in there and I can tighten this in such a way. Right now it's wobbly because it's in the wrong position, but when I get the shims moved back, I can tighten that in such a way that this front will sit flat against the 90-degree molding pieces, and when I drill, I will be drilling perpendicular to the front of this. So when those holes are done, this jack board drops in and the jacks slide up through those holes as far as they can go. Another thing to keep in mind, it's very important for all of these holes to drill pilot holes first. So I've drilled the 14 holes on the top of the case first, and I can test to see if they match up, if they're I have enough extra room on all sides by taking this board. I can just hold this by the interconnect board and make sure that it plops in correctly. It does. And I can see, everything. Some holes drifted a little bit, but again, there's 0.5 millimeter clearance. These holes, which match the connector board, I can't test to see if they're in the right spot until I get the holes drilled for the output jacks, because when you drop this down, you have to drop it down and push it through and then see if the holes lined up. So it's possible, just eyeballing it, looks like 1 or 2 of these holes might have just slightly drifted a little bit, but I won't be able to tell that until I do this. So the next thing I'm going to do is I'm going to drill all these out so that these fit, and then I'm going to double check these holes to make sure they either line up or I need to, make 1 or 2 of them slightly bigger. So I just finished drilling the holes at the back for the jacks. And I did that with this jig, as I was showing before. Here it is attached completely, and when I have it on the drill press, I have it like this when I'm holding it and drilling. These are 7 millimeter holes. I drilled 3 millimeter holes first on the punch spots, then I widened them out to 5, and then I widened them out to 7. And if you go in steps like that for the largest hole screws, then you tend to get the cleanest holes. When I did the 7 millimeters on the top, I went directly from 3 to 7, and the holes tended to get a little bit ragged along the edges. So I used this half-round file, this tiny half-round file, to just smooth them out slightly to make them pretty decent to look at. Then once I had those holes done, I could then finally go back and check the 4 top mounting holes here. And what I did was, I don't have the black button head screws that are going to go through those holes yet. I need to order those. But I have some other 2 millimeter screws. Now I drilled those holes at 2 millimeter, and I'd prefer not to have to make them larger, because you don't really want much play here if you can avoid it, because you have these mounting pins. And the other plate, the main board, when you drop this in, it mounts with those, and you don't have a lot of play. You can't be too far off with those, or you're going to have problems. You definitely would like to keep as many of them where you actually mark them and drill them as you can, so that this ends up in the right spot. I already screwed it in, and I already dropped that in and checked that it mounted, and it all worked very well, so I'm happy about that. And one other thing I noticed, which you'll have to probably do yourselves when you build the kit. When I designed the output jack board, I didn't realize, there's these spacers on the bottom which are soldered in place, and these are 2 millimeter threaded. We're only using 4 for mounting screws, and the other 4 are just basically to keep the board flat and not, wobbling around. So these back 4, they don't actually have screw holes, but just the top 4. The top 4 are all clear. The back 4, 2 of them ended up landing on this. I don't think you can see what this is in the video, but Korg has molded into the aluminum on the back these little it's like a little clock with an arrow to say when it was manufactured. So, and it's raised above the surface of the plate. So I had to get in there with a Dremel and just knock down a little bit on each of those little clocks, so that, because before when I put this in there, those 2 back spacers there were like raised, keeping the board was tilted. So I had to just get in there and knock those down. You could also use a file or a piece of sandpaper or something. I just use a Dremel to knock them down quickly. So That's all done. That means the top, this is done, this is done. I have the 3 sides to do. So I've just finished drilling the last of the sides, and now all my drilling is complete on the case. You can see the 10 holes for the rhythm section. The way I normally was doing the sides is the mounting holes are 3 millimeters, so I'm drilling those. I'm making them slightly bigger, so there's a little bit of play at 3.2. So what I do is I've got my 10 punch marks, and I put in the 3.2 drill. Then I drill all 10 holes at 3.2, so that I've got the 2 mounting holes done, and I've created smaller pilot holes for the bigger holes. Then I'm doing the 5 millimeter holes next, 4 of those, and 4 6.5. Now, don't worry about the hole sizes, because I know I'm saying these in millimeters, and some people are unaware of millimeters and using American or imperial measurements. But all of the hole sizes and stuff will be included in the documentation. But what I just wanted to point out is that it's the importance of drilling pilot holes for the bigger holes. What I've been doing for each side is, so once I have I'm making, I'll point out, on the top of the case, Korg's, for example, I'm using the same kind of pots that Korg uses on the Monotribe, and these pots have a 6 millimeter stem, and Korg has made the holes for all those pots 7 millimeters before the case was painted. So I've gone, to make everything visually identical, I've also drilled 7 millimeter holes for those pots. And I've basically done the same, the 1 millimeter clearance that they use for those pots, and also for the mini toggle switches. I've kind of stuck in this with the same pattern of quite a bit of clearance for the top plate, and also for the jacks at the back. But for the 3 sides, I've made them, because those are a little bit different looking than the top. Also, and I don't have to match any pre-existing holes. I make these holes a little smaller, and I'm sticking with about a 0.5 millimeter or 0.7 millimeters of clearance on these. So on the top, where I made those 7 millimeters, I've made the pot holes 6.5 on the sides, and the toggle switch is slightly tighter too, so that they offer the side panel, the metal case offers some support to the toggle switches when you're moving them. Now, so what I've done is I did the front plate first, and then once I finish drilling it, I take it out of the jig, and then I check it against the actual board. So I'm taking the board and I'm bringing it in here and seeing that it lines up correctly, or if it goes in. And then once I've done that, I usually find 1 or 2 spots where the hole has slightly drifted, and I either can't get the board in, I can't get it installed, or else when I try to turn the pots, I can feel they're rubbing on the side of the case. And then I'm working with these 2 small files, a half round. That's basically, that half round works perfectly for 6.5, 7 millimeter size. Very easy with good machine files or metal files, I should say, to file aluminum. It's very quick and easy. You can clean up the holes, you can extend them, make them slightly bigger on one side. So I did those 2 sides already with this half round, and also I'm using this oval. It's like an oval file, and that one is slightly smaller diameter for smaller holes. So that works really well for 5.5 holes, where the half round would be a little bit big for those. So you can see this is the one side I have. Everything's been cleaned up and finished, except this side I literally just finished drilling it. And if I take the board and I try to get it in there, I see immediately when I try to push it up, I see that those 2 toggle switches are clipping on the far edge of that. So It looks like I'm going to have to extend those holes slightly bigger. If I look visually, I can see that those holes have drifted a little towards these two holes here. So I'm just going to, also I'm going to clean these holes up a little. I'm going to run the file around all 8 of them. And I'm going to extend those holes, make them a bit bigger. And then once I get that installed, I get it to the point where it actually goes in correctly, then I will check to make sure all the pots turn freely without scraping the sides. And if there's any sides they scrape, I'll just get in there with the half round and, again, just widen the hole ever so slightly. So doing it this way, you end up with very nice, very tight holes to the pot sizes, and also the toggles are just slightly larger than the holes, so you're getting I'm getting a good support for those as well.